Hey everyone, in this video we're going to go through the second part of quadratic equations and parabolas. So so there is another video which I just saved as lesson 3-ish because for some of you it might be you've already done lesson 3 in class. So yeah, anyway, you decide whether you want to call it lesson 3 or lesson 4 or whatever. Okay. Lesson 2 was done in class, which is good to know. Let's move on. Okay, so in this video we're going to have a look at transformations and what comes after that. We're going to use the discriminant for some questions, blah, blah, blah. We're going to look at maybe domain and range. Okay. Whoops. Where am I? All over the place. There we go. All right, so this shouldn't be new to you. So in the previous video, we ended on the turning point form of the quadratic. Maybe in class we covered this. Don't know because it's Tuesday night, not Wednesday. So don't know whether I covered it in class for one of the classes. Anyway, your quadratic in turning point form. So remember we get it into turning point form by completing the square. When it's in this form, we can easily see what the transformations are. So if a is greater than 0, then it's got a minimum turning point. So basically you have a positive parabola. If a is less than 0, you have a negative parabola. So it has a maximum turning point, and there's your minimum turning point there. The vertex is at the point HK, so vertex also meaning turning point. The axis of symmetry is at x equals h. What else do we know? If h and k are positive, then the graph of this is obtained from, okay, so that's just talking about the transformations. So h is your horizontal translation, and then k is your vertical translation. All right, so for the first one, and that's the same one we did. Oh, they're the same, both same equations. Oh, great. So we don't have to complete the square. All right, so this 2. All right, so remember we did the negative 2, so h is negative 2. All right, so that means we've gone in the negative direction of the x-axis, all right, 2 units, and 7 units in the negative direction of the y-axis. There hasn't been any reflection or transformation because our value of a is 1. All right, there's no dilation factor. All right, and it has a minimum turning point. I'm just trying to think. So we did do the turning point in the previous video. So remember HK is your turning point, but hopefully you've covered that already. The axes of symmetry. All right, so let's move on to the other one because we've got quite a few transformations in this one because we've got this negative 3. When you're reading, oh man, and my foot's just gone numb because I've been folding my legs, which was not good. When you're doing your transformations, try to keep them in the order DRT. So I always say Dr. T. When you're reading it when you're reading it in this form, it's not always going to be like this. And when we do more work on transformations and mapping, you'll see why. But just always state your dilation first, then your reflection, and then your translations. Because the order does actually matter, especially if you're doing some reflections. Okay, so when you think about a parabola, sorry, I'm getting off track again. Here's a parabola. If it's been reflected first, so I'll just say along the y-axis. If it's been reflected along the y-axis, it actually stays the same. And then if it's been translated along the x-axis, it's going to go to there. All right, so that means we've been dilated, then translated. If we went the other way around and we did a translation first, we would be here. And then our reflection would bring it over here. All right, so just be careful with your order. And now that I'm thinking about that sort of question, it's probably easier to do with an example, but it's getting late and I don't want this to be a very long video either. All right, so we do our dilation first. So dilation of 3 from our x-axis. This should just be revision for you. If it's not already in your notes, make sure it goes in your notes. It's been reflected along the x-axis, so that means it's gone whoop upside down. And then we've got our translation. So h is 3/2 and k is 21/4. So there are our translations in the horizontal and the vertical, blah, blah, blah. Hopefully you get the gist. I just want to get to some harder questions, so sorry for being quick. Come on, I'm going to scroll. Did I go too quickly? Okay. So here are some questions. So using the discriminant to decide how many solutions we've got. Not difficult. We did some examples earlier, so let's move on. I just want to get to some harder ones. Express each of the following in turning point form and then find the minimum value and the range. So all of these are positive parabolas, because as I read that I was like, oh, what if you had a maximum value? But they're all positive parabolas. And I know they're positive because your leading term is all positive. So when you're talking about your minimum value, so if I just quickly draw your parabola, it's your minimum y, so that's your minimum value. And your range will always go from your minimum value to infinity. Okay, because these parabolas go on forever unless you've got a restricted domain. In these questions, we don't have a restricted domain. So you can see here your value of k that we worked out is, so if I just use this example here, even though I know it's not the right point because it's obviously not the 0.15. So that's your minimum value there, your 5, your corresponding y value. So we're going from 5. All right, and it's a square bracket because the value is included to infinity. All right, moving on to question B. So again, same thing, finding the y-coordinate of your turning point and then your range, because your range is the restriction on your y values, domain is the restriction on your x values. And for all of these, your domain, again, going on a tangent, sorry guys, your domain is from negative infinity to infinity. You'll notice whenever we write infinity, it has to be curved brackets. All right, so infinity, because it goes on forever, is not an included number. And another thing you need to remember is this always has to be your lowest number. I always see, actually, because this year did really well with this, I try to stamp it out, but I do see it in term 1 all the time. Lowest number first and then your highest number. All right, always goes in order. Don't do it around the other way because it's wrong. And get your square bracket and your round bracket correct. All right, and then in question C, you can see before we complete the square, we take out the 2. You could get your turn, just while I was thinking, you could get your turning point, because basically all we're doing is you're getting the turning point to find this value here. You can use x equals negative b over 2a. And that'll give you this, and then you just substitute it in, which now I'm thinking is probably more work than just completing the square. So perhaps just stick with completing the square. But you do you. If you prefer the other way, that is fine. All right, so here we've got, I think, some harder questions. Okay, so finally getting to some more challenging questions. And what makes it challenging is we have an equation in terms of m. And on the methods exams, they like to throw these ones in, and I like to throw them into the first sack, just so you're not always relying on your calculator, because you can't really, actually you probably could use a slider with these now that I'm thinking. You can't always do them on your calculator. All right, so maybe I'll just put a little caveat in that you can't always do them. You might be able to put a slider in for this one. Anyway, let's just assume you can't do it. I'm going to do it by hand. All right, so for which values of m does this equation have 2 solutions? So if we want 2 solutions, our discriminant has to be greater than 0. All right, so here's my discriminant here. B squared minus 4ac has to be greater than 0. And this does turn up, not only in your first sack, because I like to put it on there, but it also will turn up in exams, all right? Because you often have to think about not just x-intercepts, but when two graphs intersect, which, you know, could be, oh, here I am going on a tangent again. You might have, oh, I can't think of anything at the moment. You might have is that a log graph, and it's inverse, and you can see you've got 2 points of intersection there. So you could be doing questions like that, because as you change those equations, they no longer intersect, or they might only intersect at one point. Anyway, so questions like that you would often use the discriminant for. All right, so just identifying your coefficient of, your value of a, which is your coefficient of x squared, so which is m. B is your coefficient of x, which is negative 2m, and c is your constant, so it's 4. So you can see I've just substituted them in for b squared minus 4ac, and then we're just solving that equation. Now, you should know at this point that we've got basically the null factor law, so we can separate them to 4m equals 0. Okay, I might just say that is equal to 0 as well. I'm not putting that inequality sign there. So we've got 4m equals 0 and m minus 4 equals 0. So we know that m equals 0 or m equals 4. Now these inequality signs always can cause a bit of a headache. And what we basically have to check is when the equation is true. So we want it to be greater than 0. So with going back to 4m, sorry guys, I just had to pause because my son was messaging me. Okay, so we've got this equation here. Oh, I might go to this one here, the 4m squared minus 16m. So as we can see, it is itself a positive parabola. So if we were to sketch this parabola here, we would have 0 and 4. And it's a positive parabola because our leading term, our leading m squared term, is positive. So it's going to be looking like that. So if you think of this being your m-axis, let's try to get out of the zone of it being x. So basically, when we are above the axis, and I should say this is our discriminant, so we're graphing our discriminant. When we're above the axis, obviously our discriminant is positive. And when we're below the axis, our discriminant is negative. And on the axis, all right, so here and here, it's equal to 0 because you think of that as your m-axis goes through, your discriminant is equal to 0 here. We might do some of these in class because students often have trouble deciding on which inequality sign to use. Graphing it is probably, I think, the easiest, but getting your head around graphing the discriminant, which is different to your original quadratic, might be a bit of a concept that we'll need to work on. You can also substitute the values of 0 and 4 in to see whether it makes it true or not. Oh, sorry, not 0 and 4. Substitute in a value either side of 0 and 4 and check whether it's true or not. All right, which we'll do in class because I feel like if I go over it now, it might be even more confusing. So I'll consolidate it in class anyway. If we're looking at one solution, our discriminant is equal to 0. So basically, as we've done before, we worked out m was equal to 0. Now I know that I've got not equal to 0 there, and I'll touch on that in a second. So m is equal to 4. Now the reason why m cannot equal 0, because if m was equal to 0, then basically this term here and this term here, our first two terms, when we substitute m equals 0, they're going to disappear. All right, because when you multiply something, oh, sorry if you can hear my dog. If you multiply something by 0, those terms disappear and we'll just be left with this 4. So just always check your solutions whether they make sense. All right, I feel like I've just butchered that question. I can only on PDFs write in red pen. I much prefer Word where I can colour in. All right, solve the equation. What have we got here? So here, all right, sorry, I just had to pause to figure out what I was doing. So sometimes if you're like, oh my gosh, what do I do? And I'm just looking at this, and you could solve it using the quadratic formula, but clearly I didn't use the quadratic formula. Because you can see your value of A, your B, and your C. Although I'm thinking that will probably, although you could do it that way, it might just make it very complicate things. So as you can see, I've expanded the bracket. So I did these solutions last year for Head Start, so that's why I've got to kind of refresh my memory what I've done. So expanding this bracket, the first bracket, we get kx squared minus 2x squared, and then expanding the second bracket, we get kx minus x, and then that plus 1. Bringing your like terms together. What have we got? So we've got here at the front our k terms, if you like, and then we've got everything else over here. Now bringing those k terms together means that you can bring out k as a common factor. You could also bring out the x. So remember going back to the literal equations that we did, sometimes expanding and then factorizing and then doing some cancelling out. So taking out kx was probably a good idea, because you can see we end up with an x plus 1 on both sides. So after factorizing this expression here, we get x plus 1 times 2x minus 1. So those two terms cancel each other out. Then we're left with kx equals 2x minus 1. Then what did I do? I'm trying to think. Bring your x terms together. This is quite a tricky question. 2x minus kx equals 1, and then bringing that x out as a common factor. So we get x equals 1 over 2 minus k. Oh, haven't I finished? What am I doing? No. I think that's fine. What did I do over here? Do not know. Maybe I was doing the... No, I don't know. Sorry, guys. Yeah, so x equals 1 over 2 minus k, and k cannot equal 2, because you can see if we substitute 2 in there, it's going to be undefined. So that's what that means. Yeah, so if you had trouble with this, perhaps use the quadratic formula. You are going to end up with probably a few complexities in there, because I'm just thinking you're going to have to square k minus 1, but that shouldn't be too hard. Although then you're... Anyway, maybe give it a go. See how you go. All right, question 5. Okay, so find the values of k for which the equation has one solution and two solutions. So here using the discriminant again, so identifying the coefficient of x squared, the coefficient of x, and the constant. And then just, so for one solution, we want our discriminant to equal 0. When did I come across a question like this? I think maybe on a trial exam or something that students were doing. It's always easier when it's equal to 0, because then you don't have to decide with your inequality sign whether it's greater than or less than or whatever. So it's equal to 0. So nice to be able to solve. So you can see you've gone through the solving steps there. Hopefully you can follow, just kind of conscious of time with the video. So maybe pause it if you need to. So we do end up with, what do we end up with? We do end up with a surd. So with your surds, please make sure you simplify them. Don't leave it as the square root of 32. So going into methods, it is assumed that you know how to simplify surds. So it would have been something you did at the start of year 10 when you did methods prep or advanced maths. Yeah, so we end up with plus or minus 4 root 2 plus 6. Or you could have written the 6 out the front, doesn't really matter. All right, so there's your the values of k. Now, checking those solutions, both of them will work. So remember, it's just, you know, if we got k equals, well, let's just check if that would work. Yeah. So if k was 0, then you wouldn't have a parabola. All right, so for two solutions, your discriminant has to be greater than 0. Now, you're probably thinking, where is all the working out? Well, we did work out the discriminant before. So basically, I've used this here and changed the equal sign to the greater than sign. And with your inequalities, oh gosh, we've got k minus 6 squared. So that 32 doesn't matter whether it's on the left side or the right side. It is a positive parabola. So just quickly drawing a positive parabola. So we've got two x-intercepts. So this time k is on that horizontal axis, and here's your discriminant. So remember, anything above k, your discriminant is positive. And then anything below that, your discriminant is negative. So our two solutions that we found in the previous one, we've got positive 4 root 2, so that's going to be this one here. So 4 root 2 plus 6, and this one here is going to be negative 4 root 2 plus 6. It doesn't actually matter where. I'm just thinking now those x-intercepts are probably not drawn correctly on that graph. We just need to know when we're greater than 0 and when we're less than 0. So when k is greater than 4 root 2, so here's this point here, trying to draw a big dot. All right, so when we're greater, you can see this section here, we're above the x-axis, and when we're less than 4 root 2 plus 6, we're also above the axis. So anything in between, so if your value of k was between those two values, then you would have no solutions because you're below the axis where your discriminant is less than 0. Oh my gosh, I probably should stop this video. I'm getting really tired. All right, just make sure that there's no tricky ones. I know I'm coming towards the end. For the quadratic equation, px squared plus 8x plus 2 equals 0, where p cannot equal 0, again, because you wouldn't have a quadratic. Find the discriminant, easy peasy, there it is. Find the values of p for which there are two solutions. So we want it to be greater than 0. So here we don't have to worry about having, this is actually probably easier than the previous questions that we've done. So when p is less than 8, we have two solutions. When p is greater than 8, we have no solutions. And then when p is equal to 8, we have one solution. Now on your calculator, you can actually write this. All right, so let's just quickly do it, because sometimes it blows students' minds that they're like, oh my gosh, look what the calculator can do. All right, so come on, let's go back. All right, so we've got, just typing this expression in. Oops, that was meant, I thought it was a weird x. P times x, do make sure if you've got multiple letters that you put a times sign in between. So x squared plus 8x plus 2. All right, so remember the button that k should go for now. All right, so let's click that. Come on. I'll probably use p somewhere else, doesn't matter. All right, so there's our quadratic. You'll see that the slider came up. So if I move that, so what were we dealing with? 8. Let's put 8. Come on, keep going. There we go. All right, so you can kind of see it's touching the x-axis. Now, when we were less than 8, remember we had 2 solutions. So as I go down, see how it's crossing the axis? And then when you're greater than 8, it's above. All right, so that's all we're doing there. You can change your slider. So we're only going up to 10. You just go up to the top thing there, go to settings, and we can change that maximum. Let's change it to 20. What? Oh, what am I doing? Sorry, guys. It said current value. 20. There we go. Come on. And you can change your step. So if you want it to go up by 0.1, you can. And you'll notice that it auto plays. Let's do that. Woo, 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 woo. Okay, that's enough. All right, let's get back to this. Okay, so that using your calculator, you can actually see what's happening also. So if you're a bit unsure, use your calculator to check. But obviously, you can't always have your calculator. So, all right, question 7, and I think this might be the last one. Let's have a look. Awesome. And it's still under 30 minutes. Let's see if I can finish in 4 minutes. All right, so for the quadratic blah, 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 find the discriminant. Okay, hopefully we've done that enough times. You're probably thinking, oh my God, I don't know what that is. It's just the discriminant in quadratic form. So when we're looking for 2 solutions, all right, because your discriminant is in quadratic form, that's why we've got these 2 solutions here. K equals -1/3 and K equals 1/5. Now our quadratic, is it another positive? Oh, sorry, what am I doing? I'm looking at my, okay, so this time, I'm just thinking of the quadratic. So this time with your discriminant, see how it's a negative leading negative? So your quadratic is actually reflected one like that. So here we've got -1/3 and 1/5. So we want 2 solutions, and I probably haven't written it very well. I probably should write it differently. So basically, remember anything above where your discriminant is greater than 0. So this interval between -1/3 and 1/5 is where we've got 2 solutions. So I've written as K is less than 1/5 and K is greater than 1/3. I should really write it like this. All right, but I'd rather write it like that. And then when we're looking at C, no solutions. So remember that's when your discriminant is less than 0. So here when we are below -1/3. Oh, hello, where's my negative sign? Put it in. And then greater than 1/5. So that's why we've got the greater than and the less than sign. And then obviously one solution, which is easier because we're not dealing with inequality signs. We have these equal signs. And I've still got 1 minute and 40 seconds, but I won't keep talking. If you understood that, well done, because I'm very tired and I do hope it made sense. But we'll definitely go through some of these questions in class as well. Anyway, guys, thanks for listening. Bye.